be square, 0, and then infinity, then circle. Okay. Even though this looks weird, like there's a square here, there's a circle here, there's a rounded one, it's normal. Usually you'll find this in the answers, right? Then I'll go on the next one. Okay, there are different types of graph. Okay, this one I'll just use my notepad. Yeah. Oh, I already drew it. But the first graph, okay, as you may know, there are different types of graph, right? So there is y is equals to x graph, where it's just this, y is equals to x squared, where you have this, y equals to cube sometimes, but usually cube seldom comes out of the exam, usually, because I've done, like I said, the trial paper that I've done, most of the time, they wouldn't even come out with this, with this or this. Sometimes it will come out with quadratic, so that's something you should look out for. For cube, it's just this, okay? But I want to put emphasis on y is equals to x squared. So I'll just pattern this out for a bit. Oh. So if y is equals to x squared, this would be the graph, right? But sometimes in the question, it would want to ask you how to manipulate the graph, all right? Sometimes they will ask you like, what if they put 2 here, right? What would happen to the graph, okay? Sometimes they would put here and then sometimes have times 2 here. Usually this would be the type of questions you will be getting, or maybe like there are some other ones, something like that might happen, right? So you have to be ready with these types, and you should know what happens to the graph if this were to come out. So usually for this type, it's really simple. Basically, just the y would go down by 2 units, all right? So if I were to sketch this out, it would just be something like this. So 1 and 2, this is the origin point. So here 2, yeah. It's not a perfect, but I hope you guys understand, because basically it wants to hit this 2, right? Negative 2. Don't mind the little scruff up. Then after that, this, what does this mean? Usually it's just the side to side, if I'm not wrong. Oh, no. It is the, yeah, basically just where the x is gonna be. Usually if 2 bagi should be right there. They have like different graph here. Should be moving left to right, then 2, so it should be a bit down. So it depends on how you want to sketch the graph, but if you don't understand, you can always use the one app that I use, which is Desmos. Basically, if you're not sure, you're doing trial paper, right, and you're not sure how the graph would look, you can just type it in here. For example, the y is equals to 2x squared, for example, as you can see. Oh, it's not going left to right. As you can see, I am only human. So the graph, if I'm not wrong, is just going, it's more narrow. And then after that, if I put 2 here, plus 2, yeah, it goes down. All right? So yeah, that's mainly for quadratic, it's easy. So usually the questions I face is really easy for quadratic. But another question, another type of graph that it may ask you, and this is very important, is the Euler's number, or what we call natural log. So usually it's just this, y equals to ex. So how this graph would look is this. So I have y here, x here. So it will go from the end of the graph here, and then suddenly goes up. All right? Now, be careful when you're sketching the graph, because this should not hit the x. It's very close to x, but it shouldn't be hitting x, all right? It should be close to it. So if I show you on Desmos, it will show you the same thing where it's equal to that, and x. You can see it looks like it's hitting the x line, but it's actually not. If I zoom in, it's going on forever. It's not hitting the line at all, right? So when you're sketching the graph, make sure you don't actually hit the line because it might deduct some marks there. And then right here, for example, if I were to sketch the graph as well, I want to know where I'm putting the intercept. As you can see, it intercepts at this, right? So how do I calculate it? Usually it's really simple. You just use the SPM method where x is equals to 0. This, yeah, x is equals to 0. So usually y is equals to e0, and then you have 1, and that is the intercept, right? So the same thing can go from here, where how you want to manipulate, how do you want to manipulate the graph? I'll just rub that out. Then let's say I just put y plus 2 equals ex minus 2 here. So what would happen, right? Usually, if I put this here, it will mean that the graph is either going up or going down. But in this case, just remember, if you don't know how to do this, right? If y is equals to y plus 2, remember that this goes here on the opposite side. So if you have this on the opposite side, it has minus 2 here, right? So you can just ingat this only. Okay? You can just remember this part. Y is equals to minus 2. So remember your graph, where your graph is going to start is here, minus 2 right here, right? Maybe in the graph you want to do dotted line so that it's easier for you to visualize. And it doesn't deduct any marks because it shows that you have a deep understanding in the graph itself. So you would start from here, go up like that, right? If you want to find the intercept, it's the same process. I'll just show this part of it. Yeah. So usually what will happen here is y is equals to ex minus 2. Let the x equals to 0, so this, and then plus 2. So this is your y-intercept, right? So right here, this part is negative 1. And that should be your answer lah. And then same thing for the x-intercept, but I won't show it here because it's kind of difficult. You should be using, ideally you should be using your calculator lah. So don't forget your calculator during the exam. So usually it's something like this, minus 2. Then you have 2ex, and then here you would be losing ln, so natural log x. Here, this will be natural log as well. So your answer would probably come up to this. It will become like that. All right. So right here, this right here, it would become ln 2, right? But maybe it will, in a calculator, it will probably show decimal points. Just take the decimal points only. Maybe ideally you take four decimal points. So for example, like pi you have 3.141. You take the 141. You take 4, right? In the calculator. This is the safest answer, right? It's either you take 4 or you take 2. In complex number later, I'll show you that usually you will take 2. The 2 decimal points, right? So these are the different types of graph that you have to remember. Another type, one more, is, I'll just add one more page. One more is the LN, the Ln graph. So it's basically like the Euler's number graph. The Euler number is this. So this is Ex. But for ln x, it's like this. It's the opposite, all right? The opposite. That's all what you have to remember. And other than that, I'm pretty sure you can get it. All right. But if you have any questions, you want to deepen your understanding in the type of graph, feel free to ask. All right. But I'll just skim it over and try to summarize everything so it doesn't be a pain, because I'm trying to summarize all the different topics. So I hope you guys can like catch up lah. Like, because it's almost exam time and we're trying to cram everything, right? So this is just a summary so that it's easier to deepen your understanding for each topic. So next we have polynomial. Okay, polynomial is really easy. All right. So I'll probably just give you a question. For example, okay. So for example, I have a function. So fx, right? So fx is equals to x cubed. That's not three. X cubed 3x2 minus 6x minus 8. All right. Usually in polynomial cases, you will get these type of questions. And usually for me, these are easy marks, free marks basically, because the how easy it is to solve them, right? Ideally, you would be getting 8 marks or 7 marks out of here, and that is a lot more marks that you should be getting so that you can pass or get an A in STPM later on. So one of the factor is x minus 2 equals 0. So usually in polynomial cases, you would be using something called long division. So something like this. Oh, just tidy up a bit. And then we have x minus 2 here. And then long division is just uh, what number can make this number 0. So what number up here can turn this number so that this, after you do calculation, it becomes 0. So for example, here x cubed. So what do I need to times it with, multiply it with x so that it becomes 0? So that would be x squared, right? So x squared, it becomes this, and then minus 2 times x squared is minus 2x squared. Then after that, you have 5x. Then it's the same process over and over again. So for example, for this, plus 5x, 5x times x, you will get 5x here. So just make sure you just get the same number lah, so that it's easier for you guys. Then 5x, so here x, then you have 4x here. Yeah, it is 4x. Then after that, finally, you 4x minus 8. Then your final answer should be this lah, right? But if it wants all the roots, so for example, you already have one of it, so x is equals to 2. This you have to factorize again. But usually, how I do it is just using the calculator and just writing the answer lah. So for example, this, right? After I use the calculator, it becomes x minus 2, x minus 1, x plus 1. Sorry. Plus 1, then after that, x plus 4. So usually for polynomials, it's very easy mark. So I would advise you guys to do a lot of trial papers on this to see the different types of questions that make up, because once you understand the types of question, right, very simple and very easy marks to get. So 8 marks, 7 marks, tapao. So it's very easy for you guys to get marks there, right? Next up, I think inequalities, I believe. Oh, this is still here. Next is inequalities. Okay. So inequalities is actually for me kind of hard. If I'm not wrong, it's really just about like x minus 2 here, and then we have x squared sometimes plus 2. But in inequalities, you have to remember number line. But usually, if you want to solve this, just bring everything over and leave x alone. So, but in this case, you cannot leave x alone. So, for example, in this, what I would do is have one side be 0, x squared here minus x plus 4 here. Then it will become quadratic. So you can solve it from that way. But one thing I want you guys to remember is modulus. So I think I have the question here. Where's the question? So in modulus cases, it's a bit different. So modulus 3x minus 2, this, then x plus 3. Okay. Sometimes the modulus, it will become, it has thing in the textbook. It has this. This is, what is this? This is and, I think. Then we have unison. We have these two different things, all right? But what I want you guys to remember is that the left, once it's facing left side, it is this. If it's facing right side, it will be unison, right? I'll show you guys in a bit. Not in a bit, I'll show you right now. So what I mean by this is first, on the left-hand side, you want to change some things, all right? You want to change this first, 3x minus 2. It doesn't have modulus, but what you want to change is the sign, right there. Sign, and then everything on this right-hand side here will be negative. Negative x, negative 3. There's someone checking. So this, right? And then on the right-hand side, everything will just be the same. 2, and then this. The sign also follow. Then this. Then after that, you solve it one by one. So you solve the left-hand side first. So this will be 4x, and then here negative 1. Then you'll have negative 1, 4. This. Then after that, on the other side, you will have here 2x, here plus a plus. You will have 5. Then the same thing, leave x alone. Then you have that. But how do you want to finalize your answer? For me, how I found it to work is I do this. This is called, oh, that's horrible. What's that? This is something called builder's notion, where you just make sure you have the bracket, and then the bracket again, then you have x, then this. So you have this x minus 5, 2. Final answer, right? So that's pretty much it for modulus, I believe. Yeah, that's pretty much it. Because most of the answer you'll get the same anyways. You'll follow the same process, like do this, and it'll just be the same process over and over again for inequalities, and that's basically you get the answer, right? Maybe some of the questions are really hard that I face, but this is one of the easy questions you will hopefully get in the exam lah. So I really hope that if this actually comes out, I hope that we all can get 4 flat in the exam. So okay, we'll go for the next one, which is chapter 2, sequences and series. Right? First, sequences. You have to remember 2 things: explicit and recursive. So how do you want to identify them? Is first, explicit is when it has un, this right here. It has this right here, and 5n plus 3. Where the thing, it doesn't have like +1, +2 right here. It's like this, have +1, +2 there. It only has this, un and n. Very simple. Then recursive, it is like a bit complicated because there's un +1 here, then there's the un +5 here. So if you're able to separate them, you'll be in an easy position when you're doing mathematical induction, which Mathematical induction is very important for you to learn because a lot of the marks come from here. All right. This is mostly like easy marks as well lah, if I'm not wrong. Because some of the mathematical induction is really hard, but some are easy. And here, okay. So first, how do we do mathematical induction, right? So first, I'll think there's a question on it. One thing. So I'll just use another page. So here, we want to learn about mathematical induction. Induction. Correct. So how do we first do it? So the first step is the format marks. Just like in pengajian you will have the format marks where we need the uh, first the kesimpulan, then the what do you call this? The pengenalan, the isi-isi, and the kesimpulan. Then you get the full marka format. For mathematical induction, it's the same thing. First, but you don't need the kesimpulan. You just need the pengenalan only. Where, for example, if I have un plus 1, 5 un minus 12, the u1 is equals to 23, and un is equals to 4, 5n plus 3. First is the left-hand side and right-hand side. So, for example, this left-hand side here, u1 is equals to 23, right? And then usually it'll be like un or something. Un equals to 23, and then you have n equals 1. Then you have to prove the right side and the left side. So, oh wait, I don't think this is needed. I'll just make a bit. Okay. So, for example, this is not needed. So, basically, you just need to prove that u1 is equals to 23, right? So you have to prove that the explicit formula is the true. So if n is equals to 1, then that will mean that this is equals to 1, 4, and 5, 1 plus 3, then that will be 23. So as you can see, this and this is the same, 23, 23. So you can say that n, this is for the marker format, n is equals to 1 is true for un equals to 4, 5n plus 3. All right. How to solve inequality when it's in quadratic form? Oh, this is the question for just now. All right. Solve inequality when it's in quadratic form and should do graph. Okay. The graph, it depends because you don't really need a graph. You just need the, how to say? You just need the equation only. Wait, is there a good question there? Okay. So for example, right? I'll just do. I'll get back to the soalan later because I finished the mathematical induction first, yeah. But that is a very good question, right? So first, okay, once you've done this, you basically get the marka format already. So that's 1 mark for you already. So what's next? Okay, what do you want to do next? You want to prove the nk, and what do I mean by that is you need to do this. N equals to k. But it depends on you if you want to write this. This is something extra. For me, I advise you not to because you actually don't need to. But if you want to, yes, because it shows the how to say, it shows the NPM that you understand it correctly. So maybe like if he's in a bad mood or something, and when he sees this, oh, it's a good mood, and he will give you extra marks, something like that. But if you don't remember it and you cannot do it, don't have to, right? You just need to remember n is equals to k. So when n is equals to k, you just take the explicit formula just now. So you just take the un equals to 4, 5n plus 3. Right. When you take this, you just turn the n equals to k. So it will become something like this. Okay, plus 3. Right? Very simple. This counts as formula marks as well. Like in my exam, I got 2 marks here and 2 marks just now. Right? Then next is n equals to k plus 1. So here it is something different already. Right? So n equals to k plus 1. You just continue. We have here the recursive just now. Wait, it's not okay. uk plus 1 plus 5 uk plus 1 minus 12. Right. Did I do this wrong? Did I? Oh yes, I did. Okay. So you basically take the equation just now. Yeah. Why isn't this working? You basically take this formula just now. uk k plus 1 equals, oh, it's not that. Alamak. This. N equals k plus 1, right? So remember the recursive. The recursive is uk plus 1 equals to, this is n plus 1. This is the original one. And then 5un minus 12. So basically, when you convert this into k, it will become something like this, right? Actually, this should be here. Yeah. When you convert n equals to k, it will become something like this. Then after that, when you want to convert this into nk plus 1, it's different because you have this. Nk plus 1 you already have. It's basically that. But for this, on the other hand, it's different. Where you just take this, you take this, and then you just put it in. 4, what is it? 4, 5k plus 3. Or just k plus 1 here. Right. K plus 1 plus 3 minus 12. Right? Sorry if the writing is not that nice. Huh? Then after that, once we have this, how are we gonna solve this? Right. So very simply, when we have this, we always want to expand it. Okay, that's the first rule. Expand the thing. Not this. I want you guys to expand this. Put your emphasis on the exponent. So when I expand it, it's going to be this. Right. Minus 3. Minus 4. Then after that, what would the, oh wait, this is wrong. Okay, this, right? But I want the k to become plus 1. And usually when it is plus 1, meaning 5 times 5, right? But how do I get that without actually messing up the equation? Is that we do something like this. Times 1, 5 plus 3. Okay? So what's the logic behind this is that if you take this, right? 1 times 1, 5, it becomes 1. So it's basically essentially 5k